Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. Welcome. So in this episode, we're going to be creating a very simple chase functionality for an AI. And when that AI loses track of you for a very short period of time, in this example we'll be using 1 second, then it will resume doing whatever it did before. So that's essentially what we will be setting up today. So let's get started. First off, we need to create a folder so that we have our stuff organized. So we'll create a folder which we will be calling AI. Inside of this folder, we're going to be needing a few different things. One of the things is we're going to be needing an AI controller. So we're going to be making one of those. So we'll create a blueprint and then choose to inherit from an AI controller. So we'll choose that over here. We call that BP AI controller. So in addition to that, we also want to make use of behavior trees and blackboards. So we're going to be creating that. So we go to artificial intelligence and create a behavior tree. Call that BT underscore AI, just to keep it simple. We'll create the blackboard as well. So we go to blackboard and call it BB underscore AI. Going into our behavior tree, we will now dock it up here. We will make sure to have our settings set to open up in the main window. So all the new windows end up here. We want to make sure that our blackboard is set, which it currently has been assigned already here. If you don't have it assigned here, make sure you have it assigned here, the one that we just created. And in addition to that, we also want to get our third person character. So we'll drag him over here to AI and we'll say we want to copy here. We'll rename him, call him BP, let's call him BP AI character, like so. So he's a copy currently of the normal character that we have. We'll open him up so that we can change his settings, because the first thing we want to do is we want to make sure that he's using the AI controller we created. So we'll choose the AI controller over here so that he has that, which means that it will be making use of that when it starts to play. Then we can go to our AI controller and we can say that we want to go to our event graph. We'll remove the tick. And from the begin play, we can say run behavior tree. And here we can assign our behavior tree that we have created so that it will run when it is in the map. So now if we place our character in here, it will be possessed by an AI controller. It will start running its behavior tree and doing its thing. We currently do not have any logic in behavior tree, so let's start adding some behavior tree logic. First off, we're going to be dragging off here and we're going to be using a selector. And from that, we are going to be, actually, let's not use a selector, let's use a sequencer. It will be more understandable, I think, in this way. So we wanted to do a few different things. So one of the things we want to do is we want to have a period of waiting. So we'll add a wait. We can say that we wait for, let's say, 2 seconds or something like that. So whenever we've done whatever we're supposed to be doing here, we'll wait for a little bit. The next step is we want to walk to our character, or rather, we'll have this as sort of our patrol, our backup sequence. So we'll call this patrolling. Like so. So we'll know that everything that's running here is patrolling. So we want to find a location to walk to. We want to walk to that location and then we want to wait. So we'll drag off a task here and choose the move to. So this will move the character to a position. Currently we don't have any blackboard entries that are useful for us. So we'll start off by creating a new key. We'll make it of the type vector. So we'll say that this is our move location. Having done that, we can go back to our behavior tree again and we can say that the move to location, or the move to we're supposed to go here to, is the blackboard key for our move location, so that it will actually move there. The problem, or the thing we're lacking now, is that we need to actually figure out what that location is. So we'll start off by creating a new task. So we will call this BTT underscore find random location. This task will override the receive execute AI, which is the function that's called from the blackboard when it wants to perform this task. And here we want to say, we want to end with a finish execute, saying how this went essentially. And in between here we need to determine a location to go to. This location we need to expose outwards, so we'll create a variable here where we say new move location. We make it of the type blackboard key selector, which is then able to be used by the blackboard. We will also click on this little sign over here to expose it. This is also important. This blackboard key selector we're going to be getting like this, and then we're going to say set not as object, as vector. So set blackboard value as vector, because the vector is what we're expecting here, because we're getting a location. And then we're hooking it up like so. Before we do that, we want to make sure that we have a location here. We're going to do that by right-clicking and get navigatable. Let's see, it's random navigatable. Get random point in navigatable radius. So this one, we could also make use of get random reachable point in radius if we wanted to avoid it getting some places that are within our nav mesh, however the character doesn't know how to get to them. So either one of these are good. This one is probably slightly better and less prone to get an error. So I guess we'll keep to that one for this case then. And it wants to have an origin and it wants to have a radius for it to work as a base. And the result from this we will hook up to here. The origin will take from our pawn that we're controlling, which will be the AI. So getting the actor location for that, we'll use that as our origin. Once concerning the radius, we can just put in a random value here for now. So let's say 500, which corresponds to 5 meters, of course, in Unreal Engine. And then we hook this up like so. And if it gets a result here, it will send out a success for that. Now we have our task ready. We can go to our behavior tree again and we can go and get our task. So our task here, find random location. And now this should be enough for our AI character over here to be able to start moving, which it of course is not, because that's how demos usually work. And the problem with that is, of course, most likely because I forgot to add a nav mesh. So we'll add a nav mesh here, which is going to generate a navigatable area on the surfaces for us. We'll just expand this 50 by 50 by 10 on the scale, making sure that it probably covers everything. To make sure that it covers everything, we press P and we'll see all the green areas where it is actually have a navigatable mesh path made for it now. Let's press play again, and our character is still not moving. Let's make sure that we have put all our settings correct. So this is the AI character. The AI character is supposed to use our AI controller. It's using our AI controller. Our AI controller is supposed to run the behavior tree. And our behavior tree is supposed to be sequence going through this. Right, so tiny detail here. This task that we created, we exposed a blackboard selector for, and that blackboard selector I can't actually see, so let's make sure that we actually did that. New move location. That looks exposed and fine. Let's go check our behavior tree again. And we are supposed to be able to see it. Over here we have a self actor chosen as our new move location. This is the one that we wanted to set. So now we're setting our move location. Let's press play again. And now our character is moving around. However, it is sliding because it is a Unreal Engine 5 mannequin. So we'll need to go into our AI controller. Our AI character. And we need to, let's collapse all these categories so we can easily find. We need to go to our character movement. And we have a nav movement here. We need to set it to work from acceleration instead of velocity. And this will cause it to move around properly. So now it's moving. The next step now is to make sure that it is actually getting a perceiving of the player character, us, that it's making sure that it's following us. To allow this to happen, we need to go to our AI character and say that it should be able to perceive things. So we'll add a component for it called perception, AI perception to be completely accurate, and we'll just let it have that name by default. And the settings for the AI perception allows us to put different senses in here. So we have the senses config here. We can add more elements to our array, and we can add a default one like the sight config, which is the sense for seeing, of course. And in this, we also want to check neutral and friendlies, make sure we have all these checkboxes so that we can find anything that we want to find. And that is essentially all that the AI needs for that part. Now it is able to detect us and get information, but we need to somehow react to that, and we'll do that by going to our AI perception here and add an event for on target perception updated. This will bring us an actor, which will be the actor that has been updated for perception and what kind of information that has. And to make this a little bit clean, we'll create a macro to work with this information. So we'll create a macro, we call it process stimuli. We'll make sure that it has first a node that's called exec, and we'll name it execute, which will make the name disappear over here so it looks a little bit cleaner like normal. And we'll add another one, and we'll make this of the type actor. Where is my actor? There is my actor. Like so. We'll call this actor sensed. Next up, we want to grab the information. So AI stimulus is the name of the structure that we want to have in here. We can just call this stimulus. So this is the information that we want to feed in here. Feeding out from this, we want to have 3 different execute branches. So we'll do it like so. So we have 3 execute branches. The first one we will call follow new actor. This one will say lost track of targets, and this one will say ignore stimulus. So this will represent our different cases that we will be reaching here. So first off, we'll say we only want to perceive some actors. So what we can do is we can do something like get tag, which gets the array of tags that is on the character. And we can say we want to find a very specific tag, for example. So let's say we want to have only characters that have evil player as their tag. Copy this so we have the exact same spelling. We can now go to our original character, which is our third person character. And we'll just go in here and type in tag. In the tag here, we'll add an element and say evil player. This will make sure that our player character, which we spawn in with, will have this tag, just so we have an easy way for the AI to determine that we are what it is interested in, essentially. So that's what this does. And this will return a result as an array index that will be different from -1 if it's found. So we'll just make a comparison here, making sure that it's greater or equal to 0. That means we have found the character that we're interested in. We'll hold on B to create a branch and hook this up to then say that we have reached the point here where the true represents a character that we want to do something about. False will represent that we want to ignore the stimulus because it's not a character we care about. Next up, we want to take this stimulus that we have gotten. We want to break it. Here's all the information about the stimulus that we might be interested in. And successfully sensed here is essentially what we're going to be hooking into today. So we'll create a branch, hook it up like so, and say that if it is successfully sensed, Actually, let's remove that reroute. I don't want that. I want to do this. I'll go this, hide it, and then we'll drag it over here and have a reroute over here. That'll be a little bit nicer in my opinion. So if we successfully sensed this character that we already know is interesting, then we'll follow the new character. Or if we are not successfully sensing it, we lost track of it. That's essentially all the logic here. So going back to our event graph now, we can get our macro and say hook up all of these different things that we have done now. Depending on these different paths we have chosen now, we are going to be reacting in a little bit of a different way. So our first function is going to be follow new actor target. And we'll go back to our event graph and we'll just call that. And then we'll create another function which we call lost track of target. Then we'll go back to the event again and we'll drag that out here. So now we have our different functions. So we have these different cases. If we get a new actor to follow, we'll do this. Lose track of it, we'll do this. No stimulus, we currently don't have any logic for, and we don't really need it right now. So the first thing we want to do here is when we have a new actor that we want to follow and chase, we want to communicate to our AI so the blackboard can react to following this character. So we'll go to our behavior tree again, and we'll create a blackboard key for this. So we'll create a key, make it of the type object. We'll say this is our follow target. We want to go to the key type and change from base class object to actor, because actor has some functionality that allows us to work with it in a different way. One of those being that if we say that we want to move to an actor, we will continuously follow it in a or the AI will follow it in a very streamlined way, so it looks very nice and it doesn't like have to recalculate all the time. It does it for us. So that's very convenient. So now we have this, on the behavior tree here on the blackboard, we have this follow target. So let's copy this name, go back to our AI character, create a variable which we call target, let's call it follow target key, and we'll make it of the type name. This is so that we can identify this, because Unreal Engine identifies some things by names, of course. So the follow target here is what we're going to be saving here as our key. And now in the follow new target, we're going to be saying get blackboard, which gets the blackboard for this AI, which is the one that we're currently running up here, the BB AI. And we're going to be setting a value as object. And we hook it up like so. And the object that we're going to be following is going to be the actor that we want to follow. So we'll hook up that there. And we'll say this is our target to follow. And the key name here is going to be the key name we just defined earlier, so that we have it like so. Since this is a function, we'll be tidy and create a return as well, like so. And we'll go back to our event graph, and we can now see that we have a target to follow here that needs to be filled in, which we have currently not filled in. So let's hook up the actor, and the actor is the one that's coming from over here. And we'll have a little bit of a rerouting here to make it a little bit more readable. So this means that when it updates now and it says wants to follow a new actor, we're going to be sending that in. We're going to be sending the information to our blackboard. Our blackboard currently doesn't do anything about this, or our behavior tree rather, because it's currently only having this functionality here. But what we'll do now is we'll put in a selector here and have that one point to our patrolling. But we'll also make another sequence which it has as a higher priority here, if it can do that. And what we'll say here is we want to do this part, which is follow player without the sequence. And this we want to do only if we have a target. So we'll say here that we want decorator on this, and we'll say we want a blackboard decorator. This means we can check against the blackboard key. So we want to say we want to have, we need to select the decorator here as well to be able to change things here. So we want to say here on result or value change. On value change, we want to abort both lower priority. So if we're executing over here and this is updated, we want to stop that. And if we're going over here and this changes, we want to stop that as well. This is so that if we are currently following a player and it changes, we don't want to continuously do our things down here. We want to go and see if we're still able to go in here or if we need to go into our fallback over here. The blackboard key that we want to check against is the follow target, which is our actor that we have set, and we want to make sure that it is set for us to be able to go in here. With that in place, we do want to have a wait node here, just as our fallback in here as well. It makes it a little bit clearer what's happening. And we want to have a move to that goes to our follow target up here. So we'll change this to our follow target. So now essentially we have all the logic that we need for the AI to find us and follow us. So let's see if that works. The AI has an AI sight of 90 degrees, which means that it needs to approximately at least look in our general direction to follow us. But you can see that it sees us, it follows us, it waits for 2 seconds, and then it tries to do it again. So it's working. We do have a problem now that the AI doesn't give a crap about if we are hiding or anything like that. It knows where we are, wherever we are in the world, which is not essentially what we're looking to create. So let's fix that. Now we go to our behavior tree. This is good enough. What we only need to do is make sure that the follow target here is actually reset when we lose track of our opponent or the player. So we'll go to our character again and we'll create something for our lost track of target here. In here we will say we want to give the player, don't want it to be a goldfish. We want it to be able to like at least perceive the character or remember it for a little bit before it loses track of it. So we'll do a timer by event. Actually, let's do a timer by function name. And this will allow us to say that we run a function whenever a certain time has gone. So we'll promote this to a local variable and call this our memory duration. We'll hook it, actually it's already hooked up. And we want to have a function name. So let's create a function which we can call something like forgot about target. So whenever this is called, then we've forgotten about our target. So let's go back to our function and we'll say that we want to call that function when that happens. And once we're done here, we want to actually, let's do this also. We'll promote this to a variable and then we'll return. This timer handle that we created over here from this timer function we'll call memory duration timer. The reason we're saving this is because we want to be able to later on clear out this timer, because if we have a situation where the AI sees the player goes behind the corner and then comes back out again, this timer might execute while it is being seen and might lead to some unwanted behaviors where it's like sort of seeing something, forgetting about it, and then if we are unlucky it might like try to run away from us and things like that. So we want to clear this out if we are again tracking our target. So let's go back to our follow new actor target again and actually do that. So when we have reached the point where we have acquired our new target, we want to make sure that our timer is no longer running because we are not interested in that. So we're going to be clearing this timer and invalidating it. We hook it up like so. Then this should make that part work better. Now going back to our lost track of target, this is all that this needs to do. It just needs to start the timer and then say we have lost track of target. The forget about the target, however, needs to do some other things. Here we need to get the blackboard. Here we need to say set value of object. And the object in this case is going to be null because we lost track of it. And the key is going to be the same key as before. And then we're going to be returning. So if we go into our lost track target, the memory duration here will decide how long the character needs to be out of line of sight for it to forget. If we put it to 1, it should forget about us in 1 second. So that's good enough for us to try this out, I think, in a reliable way. So we'll go over here, get its attention. We'll run behind the wall. Hopefully we have 1 second here. Probably not enough. Let's go run around over here over the edge. Let's keep out of its way for a bit. And see, now 1 second passed and it went back to patrolling. So that seems to work fine. Let's see if we can get its attention again here. By jumping up on this blue box. We have its attention. We go hide. 1 second passes, it forgets about us. So that is in essence what we wanted to achieve. And we're doing it in a fairly modular way as well. We have behavior trees, which is good and flexible, so we have that, so we can easily change this and make it more advanced or less advanced or build upon it if we want to. We also have everything built here in some modulated ways where we have a macro which determines the different flows. So in here you can have different validations to see if it's something that you want to act upon or not. You have some different paths generated from that. You have some functionalities which encapsulate what you want to do when these different situations happen. So yeah, I hope that all made sense and that you were able to follow along. And that's all for now. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.